is another one of those relatively simple setups. As we talk about the idea of compound events, we're looking at, I think the easiest way to talk about it is something like this. When you have a deck of cards, what's the probability of getting a jack or a club? What's that? Correct. What do? What is it? Take it out, exactly. So how many jacks are there? 4. Okay. So the idea here is that the probability of getting a jack or a club, well, you've got 4 jacks out of the 52. How many clubs are there?
1/4.
Well, hold on. I'm just saying that you are probably getting a jack or a club. There's 13 clubs. Which one of them is a jack that you got to back them out? So you're basically, the idea here is you're looking at a probability, but sometimes you might be over counting something. Sometimes you have probability where you have to back something out versus, so this would be what, 16 out of 52, which is 8 out of 26, which is 4/13. Is that right? Okay. Versus the idea of the probability of a 7 or a jack. What would be the probability of a 7 or a jack? A 7 or a jack? How many 7s are there? How many jacks are there? Oh yeah, you just got stuck. You were thinking about the same thing, weren't you? So the idea here, the difference is that these guys don't share an overlap. What's that? They're just two different parts here. This one is what you would call mutually exclusive. You guys have heard that before, right? Well, it's just a term we use. So 8 out of 52 goes what? 4/26 2/13. And that would be your probabilities. Again, nothing too crazy, not too difficult to work through and all that. Just like, what do you mean yet?
And then it's just like, here's this really hard thing that you have to learn how to do in like a day. We say it's the smile on his face. I don't know what you're talking about.
I don't know what you're talking about. We did that one. A or B, we did that mutually exclusive. Okay. So don't write all this out. This is you know this. And this is the idea of this whole idea of mutual exclusivity. You have the unions, the ands or the ors, and things like that, like Loftus was writing up here in a second. What we have here to find whether or not, if like you have the idea of the probability of A or B, you have to see whether or not when you're writing it out or looking at what you're finding probability of, is there something where they're exclusive or do they have something in common? So, I'm trying to think of another example. The probability of selecting a student that takes math at the high school. Well, not everybody's in a math class. I mean, so you have to count up all the students that take a math class. Would be a lot. Yeah, if I'm trying to think of a way to word this, that would be. No, that's a bad example. Never mind. We'll just pull it up out here. It's the idea that it's very simple to think about because you're just looking at adding the probabilities together. The probability of rolling a die and getting a 2 or a 3. 2 out of 6, which is 1/3. Okay. Now, you're not going to roll out and do that. That's an easy one you don't have to worry about because they're independent of one another. So, this is where, got this little shrunk here. The idea here is when you have mutual exclusive versus or two events where you have one with an overlap. So the probability of A or B when you had the jack or a heart, well, you got the probability of having a jack, probability of having a heart, then you back out what they have in common, jack of hearts. The probability of a 7 or a jack, they have nothing in common, so you just add the probabilities together. That's really all this is. Should be. Got a couple examples. Yep. Homework's up for today, homework's up for on Monday, so if you get rambunctious, you got extra time, same stuff. Same stuff. What's that? Remember, you have a test this Friday, so. Yeah, I think we'll be done with this stuff by next Friday. I think that's pretty decent. Okay. I guess really the only weird thing that you can do with this when they're looking at the probability, did you guys got this? Is if they throw it in here, oh, I'm sorry, I got ahead of my examples here. What's the probability it's an ace or a face card? How many aces are there? How many face cards are there? 12. Are aces face cards? No. So these are exclusive. So you have the 4 out of 52, 12 out of 52. And that's what? 8, 20, 4/13. And so you get that. You know what we haven't done yet this year? We haven't gone to Judkins and done the pick a card or switch by that. Yeah. Oh yeah. Gotcha. Card is randomly selected from the standard deck of 52. What's the probability of the card is a heart or a face card? It's red. It's red. How many hearts are there? There are 13 hearts. How many face cards are there? 12. Of those face cards, how many of them are hearts? You just let me know. You were counting me. I'm just kidding.
We all get a card.
He brought math school or something, and so this made extra credit for every single person except Lucio, and they've agreed with his title, not Lucio.
All right, before we do this, so that was fun.
Yeah.
People watching this recording are going to listen.
Well, I paused it.
I know, but still.
I know, it's fine. So I've done that. I think we've done that to Judkins' room. He's been teaching now for 5 years. I think I've done that for 5 years straight. It's just we always take a day, 3 of us.
Got that right, Sue.
It's 25%.
Anyway, so when we're looking at this, we have those quick little formulas there of the ands and the ors. So when they're talking about the idea of figuring out one, think of it this way. If you have probability of A or B, and it winds up being probability A plus probability B minus A and B, versus A or B is just A plus B, they're setting you up for basically, this is 4 parts, they could give you 3. The other one's 3 parts, they could give you 2, solve for the other. It is nothing more than a one-step algebra problem here. So if this one here, if they're saying that the, excuse me, find the probability of A and B, if you know 3 of them, find the 4th, which of the 2 are you using? Again, notice there are 3 parts that are asking you to find the 4th. The 2 formulas, one of them has 4 parts, the other one has 3 parts. If they give you 3 of them, it means you have to use one that needs 4. You see what I'm saying? It's not that you have to try to, I don't know if it's mutually exclusive or not. It's quite, I know I say it seems simple, but you guys are worried about the other shoe to fall, and the winds are going to change and things and stuff. So this is bear with me here. 0.8 equals 0.7 plus 0.2 minus what? So what's 7 plus 2? 0.9 minus what is 0.8?
0.09. Woo, math.
Thank you. Good work. That was a good job. Proud of you guys. I know it's Friday and it's sometimes it's tough. There's a lot going on. So good luck. This is easy. I don't need to worry about that so much reading. Oh, compliments. You do look nice. So a compliment, a compliment is sometimes you use compliments to figure out large probabilities, so you don't have to count as much. The other day we had that when we had to do the counting thing for fish. Remember, like the 3 fish thing you had, where 3 or more groups, or groups of 3 or more up to 10. One of the things you could have done is done the 10 and then subtracted out 3. It's another way of solving things out instead of doing it as much math. For example, you'll understand this as soon as I show you this. What's the probability of rolling a 3 on a 6-sided die? 1/6. So 1/6 is that. What's the probability of not a 3? 5/6. Basically, what you're doing here is that means you could have rolled a 1, 2, 4, 5, 6. Well, the easier way of doing it is figuring out, well, what's the probability of rolling the 3 and subtract that from 1. Okay? Because probabilities will never be greater than 1. So if the event is in fact occurring, you just back out the probability of what you're looking for, and then the leftover is there. Okay. The probability of not getting, or the probability of not getting a jack. Well, not getting a jack would be, well, let's think about it. Probability of not a jack. Well, the easiest one is, well, how many jacks are there? 4. So it would be 1 minus the 4 out of 52. Yep. Or write it automatically, write it as 1/13. 12/13. Okay. That's what this means. You'll use this a lot when they're talking about sums. When you talk about sums when you're rolling dice. What is it? What's that?
No.
Yay! This works a lot with dice. When they say the sum is not 8. So remember the other day we talked about when you roll 2 die? If I want to do the probability of a sum not equal to 8, well, instead of trying to count up all the ones that don't equal 8, just count the ones that equal 8 and subtract it from 1. Okay? So the probability of the sum not equal to 8, well, how many ways can you roll an 8? Well, 1, 2, 3, 4, 5. There are 5 ways I could roll an 8, which means every other one is not an 8. So it'd be 1 minus 5 out of 36. It's just an easier way to count large numbers. Using complements is an easier way to do it. Sometimes they use it with a prime. They'll use like a little tick mark to show it. What's another one they do? Sum is greater than 4. I want to do the sum is greater than 4. Instead of counting up a bunch of them, It's a lot easier just to count the ones that are greater than 4. Does that mean I include 4? No, so I want to figure out which ones sum to 4 or less. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6. And there you go. Confidence. You look nice. Even though it's the opposite.
That's the second time.
You look
Usually it's calling things.
I never called anybody stupid.
How do I word this?
That would be mean. I would never call
You
anybody stupid.
insinuated what's left.
Who's next? That's me.
Exactly.
Do those.
Wow, we still have 13 minutes. 4.